So on the quiz, some of these I'm going to change the numbers a little bit. So if we have a circle and we're asked to find the perimeter, remember perimeter for a circle is the circumference, and circumference is just pi times the diameter or diameter times pi. And if we're given that this is 5 inches, what's the diameter? 10 inches. So that would be pi times 10. Of course, I changed the number. Your number would be a little bit different there. So once again, I'm going to change the numbers on you here, but same idea. So for number 9, perimeter. Well, for this one, this number that's down here means nothing. Yeah, 35, 17, 35, 17. And just add them up. So for this one, that would be 104 inches. Again, I changed the numbers, so yours will be different. Where that would come into play is if instead of perimeter, I was asking for area. So if I was asking for the area of this, we would need to know this height right here. To get that height, we have to use our a squared plus b squared equals c squared. But we have the hypotenuse, so we're subtracting. So it'll be the square root of 17 squared minus 8 squared. If you do that on the calculator, it's going to give you 15. Oops, let's returns on. So we get 15. So this is 15 inches. So the area would be 35 times 15. What was that, 525? Square inches would be the area of that. So that's where that comes into effect. So if I ask you to find the perimeter and area for something like this, this, by the way, is similar to number 5, just very different numbers. First of all, how do you find the perimeter? 33 plus 30 plus 11. You got it. So what is that, 74 feet? Now we use that to find the area. What's that? Semi-perimeter, yep. So it's 37 feet. And then to find the area, we do what?
37 times parentheses 37 minus 30 feet. Parentheses times 37 minus 30. Parentheses times 37 minus 11.
Perfect. So if we're going to punch that in the calculator, second square root, 37 times 4 times 7 times 26. 164.12 is what we would get here. That's square feet of area. Any others off the quiz that you need any hints at? We're good? All right. Do you need some time to finish those up, or are you ready to turn them in? Turn them in? All right, I'll come grab. Hey, I want you to try a couple now in your notes for us. So I want you to find the perimeter and area of this. That is a portion of a circle. This here would be the center of a circle. And I want you to find the perimeter and area of this.
Look on my history notes. This is the first page. This is on one movie. You told me to take it as many notes like this.
So I'm going to highlight the piece here and oops, maybe I'll try to highlight it. In purple here. For number 2, I want the perimeter and area of this piece in purple. So I'm going to give you a couple minutes to try those in your notes, and then we'll go over. So let's start for the area.
And then you would subtract you get the two fraction and pick up 60. 27 would be 60 or something like that.
Yeah. So you get the area of the whole circle here is going to be pi times 15 squared. 15 squared is what? 225 times pi. There was a day when I could have done that in my head, but we're getting old. Giving us 706.5. That's the area, and that is in square inches of the whole circle. So then for the sector, there you go. So just times 27 divided by 360. 52.99 square inches. How about number 2 we plan on taking some time with. How about the perimeter for number 1? Yeah. So pi times 30 for circumference. Where did I get 30? 15 is a radius, so times. We're still looking at number 1. That's the circumference of the whole circle. So that means we have an arc length, 94.2 inches times 27 over 360. Which will be 7.07 inches. Well, that's this arc length here. To find the rest of the perimeter, what do I need? 15 and 15, right? To find the rest of the way around. So the perimeter, 15 plus 15 is 30, plus 7.07 is 37.07 inches. What do you think? Could you do it now is the question. No? We'll do another example of that then in a little bit. See if we can get you there. Number 2. The key to this one is knowing what this central angle is. It's not labeled, but we know it has to be how many degrees? 60 degrees. The reason we know that is it's a triangle with all 3 sides the same, so it's an equilateral triangle. There you go. So now to find the area of that little purple piece, we start out by finding the area of the sector. So we're going to find the area of the whole circle, which will be pi times 20 squared. Yep, which is going to be 1,256 square feet, right? So then from there, we find the area of the sector by doing the 1,256 square feet times 60 over 360, which is what? 209.3 square feet. 0.33. Now, that's the area of the whole sector. That's this piece all the way outside. Let's subtract out the area of the triangle. To find the area of the triangle, the perimeter, where did I get 60 feet? 20 plus 20 plus 20. So that means we have a semi-perimeter, 30 feet. So an area of the square root of 30 times 30 minus 20 times 30 minus 20 times 30 minus 20. $173.21 square feet. Subtract those two, we get what? 36.12 square feet of area. Not so bad. Okay. Now we still need to go back and find perimeter. The perimeter of this is actually relatively simple. For the perimeter, we find the circumference of the whole circle. That's pi times 40. Where'd the 40 comes from? 20-foot radius, 40-foot diameter, right? So that whole circumference is 125.6 feet. So we want an arc length. The arc length is this length out here. That's going to be the whole circumference, 120. Oops, I don't know where that came from. Let's try that again. Of 125.6 feet times what? 60 over 360, which is going to give us 20.93 feet of arc length. To get the full perimeter, though, what do I have to do to that yet? 20.93 is this out here. I need to add this 20 inside, right? Come on. There we go.
Keep it that way.
Plus 20. So 40.93 feet is the perimeter. So to compare on these two, this one over here, I took the arc length and I added the radius twice. Over here, I took the arc length. Why did I only add 120 to it? Well, because the piece doesn't go all the way into the center. I'm just looking at this piece out here. So it cuts across here. It's not going to the center and back out, right? And it's just designed that that length is the same as a radius. It's not a radius. It's just the same length as a radius. Well, let's have you try one that might be a little bit easier. And once again, Find this area and the perimeter of this. I'll give you a couple minutes and we'll go over it. Let's take a look and see how you're doing here. So our first thing we want to find here to find this is find the area of that sector in red. To do that, we find the area of the whole circle. To find the area of the whole circle, it's pi times what? 32 squared, right? 32 squared is 1,024. Pi times, is that 3,215.36? Does that look right? Okay. So then, to find the area of the sector, it's that area, 3,215.36. Now, I know we could just divide it by 4 because 90 degrees is a quarter circle. But to stay consistent with what we're going to have to do for the others, we'll do times 90 divided by 360. Oh, what is that? 803.84 square inches. So that is the area of the sector in red. Do we have any questions on how we got there? How many of you are confident you can get that far? For those of you that are not, where did I lose you? You see? You totally lost, Nathan? Okay, so we're finding the area of a piece of a circle. So you got to find the area of the whole circle first. That's what we did here. We're just squared times pi, yep. Then to find the area of the sector to the pi wedge is this central angle here at the center of the circle over 360. So we took the area of the whole circle, right there, then just multiplied by that angle of 90 degrees, which is that angle, over 360, which is a full circle. And so basically all that is saying is this is what fraction of a full circle that we have. So we have that whole sector is 803.84. To find the purple slice, though, we have to subtract off a piece. What piece do we have to subtract off? The triangle. Now, this triangle is a little bit easier to find because it's a right triangle. So we find its area simply by doing what? Get back here. 32 inches times 32 inches divided by 2. 512 inches squared. So now we subtract that 803.84 inches squared minus 512. So 291.84 square inches. We'll pause there. Any questions? Pi times diameter is finding the circumference, the distance around it. So what you're having here is area is pi times radius squared. The perimeter of a circle, or the circumference, is pi times diameter. Okay. And so the pi times diameter, the circumference is what we're going to need to use next for the perimeter. So to find the perimeter of this, we need to find the arc length of this piece right here, from there to there. And to do that, to find that length, we find the circumference of the whole circle. So that'll be pi times 64. Good. 200.96 is correct. Oops, got an extra 0. And that is inches. So then to find that length, we take the full, so it's the arc length that we're finding. We take the full circumference, 200.96, times that central angle here, which is a right angle, so 90 degrees, over 360. So 50.24 inches. So then to find the full perimeter, this is 50.24. Then there's only one other side to it. That's this piece over here that we do have to calculate by using square root of 32 squared plus 32 squared. 42.25. So I cheated when I punched that into the calculator, but normally you do the square root of 32 squared plus 32 squared. You get 45.25. Now what I did is a construction shortcut. When you have a square, and it literally a square, so it has to be the same length on both sides. The diagonal is just the length of the side times the square root of 2. So if I do 60 times the square root of 2, that gives me that 84.85. We'll double check that. If I did the square root of 60 squared plus 60 squared, I get the 84 point. Oops. Did I do something wrong?
Oh, you did square the second 60.
That would do it. Thank you. Yes. 60 squared plus 60 squared. That'll make it work. So there is 84.85. So anyway, here we have that 42.25 that has to be added to the 50.24 to get the full perimeter. That adds up to be 92.49 inches of perimeter. A little clearer, a little easier. Oh, sure. I'll wait for you to get it written down.
So 5 times the radius squared equals the
Area.
Circle,
Yep.
and 5 times the diameter equals
The circumference, the distance around it. Yep. What's that? Perimeter is just a circumference. Yep. So let's do perimeter and area again. I'll give you a couple minutes. Let's take a look, see which one of you is right. So yes, this interior angle here, the central angle has to be 60 degrees because it's equilateral. So I'll find the area of the whole circle will be pi times 74 squared. 3.14 times 74 squared, 17,194.64. square inches. Yeah, close enough. So then, to find the area of the sector, 17,194.64 times 60 over 360. That's right. 2865.77. Yep. That's square feet. Now then, for the triangle, square inches. Thank you. For the triangle, yep. So the perimeter is going to be just 74 times 3, or 222, right? So the semi-perimeter, 222 over 2, which is 111 inches. Yeah, square root of 111 times 111 minus 74 times 111 minus 74 times 111 minus 74. So square root 111 times 37 to the power 3. 2371 is 18 square inches, and then we subtract those two to get 494.6. Looks good to me. 59.6, close enough. It was 494.
Use my paper and say that's what I got. I actually didn't look at it. I got 492.60. Yeah, 494.6. You get it.
What's a few thousand square inches amongst friends? Yeah. Yeah, you put 72 square feet over 1. The square feet will go on bottom, square inches on top. 1 square foot's 144 square inches. So the square feet cancel out. So 72 times 144, which is 10,368. Be nice now. I'll give you a second to do the square feet into square yards.
Square yards, I just divided by 9.
Perfect. Yeah, square feet on bottom, square yards on top. 1 square yard is 9 square feet, or 3 by 3, which is 9.
I got 14.6.
14.6? You're absolutely correct, Peyton. 14.55555. There you go. From the naughty list to gold star in one move. How about these?
Easy. Oh, actually, I don't have my calculation. has all the conversions in my
In your calculator?
calculator. Well, it was my sister's, and she wrote them all in there. I got my calculator from her.
So then over here, yeah, millimeters to meters is 3 spots to the left on the chart. So squared means it's 6. So 1, 2, 3, 4, 5, 6.28 is correct.
Oh, baby. Oh, baby.
Thank you. So here, let's take a look. We've got 88 feet, 124 feet here, and 152 feet here. I want to know how many acres that is.
Oh, I like 43,560.
Cool. So, of course, the first step is going to be to find the area of this in square feet. This shape is a trapezoid. Those two lines are parallel to each other. How do we find the area of a trapezoid?
88 times 124 times 152 and then somehow.
It's the average of the bases. So the 124 or the 152, you add them together and divide by 2, then multiply by the height. Usually I put the height afterwards, but it can go either place. So add them together, divide by 2, then times the 88. We get 12,144 square feet. Now to convert that into acres, Damon had it 43,560. 60, yeah. 0.27 sounds correct.
Well, 0.28.
28? Okay. Acres. Okay, we are at break time, so take about 10 minutes. Then we do have a quiz. Let's go ahead and go through this one. So let's start out with perimeter. Only because doing the perimeter is going to give away some of the things we need for the area. One of the things I need to know is this distance here. So let me lead you to it. What's this distance here have to be? 6 feet, right? Just because 8 and 20 or 8 and 12 makes 20, so 14 and 6. If that's 6, this has to be 6. Because that's one of the things we'd mentioned about a circle is a circle or a portion of the circle can translate horizontal dimensions to vertical or the other way around because the radius has to be the same in all directions. That's 6 feet no matter what direction you measure it. So now this has to be 13 minus 9 is 4. So 4 feet. So now there's 2 pieces we need to find in order to put the perimeter together. We need to find this length right here. How are we going to find that? So the square root of 8 squared plus 4 squared, 4 squared plus 8 squared, either way will work. So second square root, 8 squared plus 4 squared. Yes. 8.94 we get. Feet. Then we need this length here. How do we find that length? Well, we're going to find the circumference of the whole circle, which will be pi times, not 6, but 12. So 3.14 times 12 gives us 37.68 feet. And then what do we do with that? We find the arc length by doing 37.68. 90 over 360. Good. So we get 9.42 feet. So then the perimeter is 9.42 plus 7 plus 12 plus 8.94. And my writing is really sloppy for some reason. Plus 9 here, plus 14 there. So we add those up. So what do we have there? 20, 27, 36, 50, 59, 60.36, I believe. Feet. So there's our perimeter. Next, we need to find something seems off there. I'm going to just add those up because I don't trust myself at this point in the day. It is, okay. So for area, this one's actually easier than it looks for area. Exactly. So we're going to find one big rectangle, this big rectangle here. So that's going to be 20 by 13, right? So 260 square feet is the whole thing. And then if we subtract out this triangle here is 4 by 8. 4 times 8 divided by 2 gives us 16 square feet. We subtract that. Yep. So it's 244 square feet. And then we have this quarter circle here. So pi times 6 squared gives us 108. Oops. 3.14 times 6 squared. 113.04. That sounds better. Square feet. And then, of course, we have to do that times 90 over 360. Giving us 28.26. So we have to subtract 28.26 square feet more. So that's 215.74 square feet of area. Things that are looked like this.
Tuesday. Pretty sure.
You guys do all have your student IDs that I gave you. Okay.
I think I wrote it down on my quizzes and lost it.
It's your login for Blackboard to get into Blackboard, and you actually have a college email account and all that stuff. So this is an octagon because it has 8 sides. It's what we call a regular octagon. At least it should be if I could draw, because all the sides are equal. What's that? Yes. All the sides are equal and all the angles are equal. Yeah, you could have an octagon that actually looks like this. It's still 8 sides, it's just stretched out in one direction. Or you could have an octagon. That's an octagon. That's very irregular. But it's still 8 sides, so it's still an octagon. Finding the area of something like that would be a nightmare, so we're not going to do it. But we are going to look at regular octagons, and actually hexagons occur if we were to do the second semester of this math course we would actually get into regular hexagons and finding their area as well. Octagons are a little bit simpler. To find the area of a regular octagon, there's one of three features that we need to know. One would be the length of the side. We'll label that with an S, call it side. Or we could link the length for inside from one flat side to the other. We call that F for flat. Or we could go corner to corner. We call that D for diagonal. Sounds like something's still dragging there. So, anyway, if I want to find the area of a regular octagon, that one doesn't sound like a bus. Oh, it is a bus. So anyway, the area of a regular octagon, if I have the side, the area is equal to 4.8275 times the length of the side squared. Now this formula is in the packet I gave you, the big area and volumes packet. This is on page, I believe it's page 170 or 169 in that packet. So if you don't want to write them down, you don't have to. So if I have an octagon, let's say you're going to build a gazebo. And you're going to make an octagon that's 8 feet on a side. The area of that octagon is 4.8275 times 8 squared. Always 4.82 if you're using the side. Yep. Oops, 75 times 8 squared, giving us 308.96 square feet. Yeah, every one of these is 8 feet long. So the area then is just 4.8275 times that side squared. That comes from trig. So using the fact that if you divided this up, this is 8 feet. This is 8 feet, I should say. This length is 45 degrees, sine of 45 degrees times 8 feet. There's a little bit of a mess to it, yes.
So since you put like the S there,
Yep.
instead of like 8 for all octagons, so that like works for other.
Yeah, so whatever the length of this side is goes in there, and that would give you the area of that octagon.
Oh, well, for only octagons?
Only for regular octagons. Yep. Yeah, this number is only true for octagons.
Alright, because I was looking confused if you could put other numbers for the side.
You can put other numbers for S, but only if it's an octagon. So if this was let's do another one. Let's say that we have, let's say this is 15 feet on a side, right? So that area is 4.8275 times 15 squared.
Oh, I was
Okay. Yeah, the fact that it was 8 and there's 8 sides kind of is a little coincidental. Yep. Yeah, so that'd be 1,086.19 square feet. What if we know the flat distance? Well, then the area is 0.8284 times that flat distance squared. So this would be if you're going to build a gazebo, and let's say you have 20-foot timbers, and you want to make it portable. So you got 20-foot timbers. Those 20-foot timbers will extend here, so you can put it on a truck or a trailer. That means their flat distance is 20. So the area of that will be 0.8284 times 20 squared. Giving us 331.36 square feet. Or if what you know is the diagonal, then the area is 0.7071 times that diagonal distance squared. Let's say you need to fit this. This is actually one that I encountered. They had a round silo base that was 20 feet in diameter. And they wanted a gazebo built on top of that base. Well, the 20 is corner to corner. That is the diameter of that circle that would contain that. That would be the corner to corner. That's the diagonal distance. So the total area of that will be 0.7071 times, now diagonal is 20 feet, so 20 squared. Giving us 282.84 square feet. Or we can work this backwards. Building code in most municipalities is for like a garden shed. If you don't want it to go on your taxes, it has to be under, or if you don't want building code to apply to it, has to be under 100 square feet. So I want to make a gazebo that's a regular octagon. Now this is obviously going to end up being like a kid's playhouse, not a big gazebo because you're not going to fit a picnic table in it. But I want the area to stay under 100 square feet. So I want to know what the length of the side is going to be. So 100 square feet equals 4.8275. Yeah, you're exactly right. What are we going to do? Other way around. Divide by the 4.8275. So 100 divided by that gives us that S squared is 20.71. And then what? Square root it. So the square root, most of your calculators do have an answer key. Okay, so your size is 4.55 feet. So that's about 4 foot 7 inches is the length of that side. So that's not tiny, but it's not going to be big enough to put much in it. I had one guy wanted me to build one with 5 foot sides on it. And yeah, you could barely put one of those small little plastic patio tables in it and then get chairs around it. Still rough to get around it. It's not much size there. Okay, so in your packet, you have page 170 deals with octagons, regular octagons.
Who's on trying to throw up? What? It's like you're trying to throw up. That's gonna be really
If you're done with it, I'll take her now.